Hey guys, welcome back. We're on question number 4, so let's do it. We talked in the last group, which of the following sources of error is included in the margin of error? The only thing that's ever included, so let me write that down. The only thing ever included in the margin of error is chance variation. Now, are there ways to do other types of errors? Yes, but inside the margin of error, the only error ever included is chance variation. And you might be thinking, well, I don't even know what chance variation is. So what is chance variation? Randomness. So what do I mean by that? Well, back to your notes earlier. Again, if I took a bunch of general data, how much money do students make from a population of 10 million, and I created a table and I only asked 100 students, I'm going to get numbers, a lot of different numbers, and I'm going to add up those numbers, divide by 100. I'm going to get a number. And if I do that again, then chances are the same 100 students will not be picked if I gave all 10 million students an equal chance of being chosen. And so chances are if I do the same exact thing again, but I just pick 100 different students, just because of this ability to, it's just totally random, then that new average should be slightly different. And you might be thinking, well, why is it slightly different? Well, it should be slightly different because you're picking different people in the sample itself. That's the variation. Not that these people changed their mind. You call them back and they said, oh yeah, no, I only make $3,800. I told you $4,800. That was a mistake. There's going to be other errors, but those errors are not included in the margin of error. The margin of error only includes this randomness component. All right. Question number 5. What is the critical value for T star for a 90% confidence interval when n is 15? So let's write that down. What is a critical value? All right, a critical value is a Z star or a T star. So when and why would you do this? If you're dealing with a proportion question, that's a yes or a no, you're always in a T star situation. When else would you be in a T star situation? If you're doing a means question where you are measuring something and you have sigma, the standard deviation of the population. So when do we call this a T star? That's when you're doing a means question, which is you're measuring, and you only have the standard deviation of the sample, okay? So that's where we stand. And what is this critical number? It's the one that determines the width of your confidence interval. So notice the more confident you are, the more wider you need to be because you need to be more confident in your approximation and you need to take into more variability. All right, so using this table in question 5, it says, what is my T star when I'm using it for a 90% confidence interval and n is 15? So how do I use this table? This is called table B, and you use it, the rows on the right are called the degree of freedom, which is just n minus 1. So our degree of freedom here would be 14. So I want to go on the table and find the number 14 and follow my finger across the row. Then what does the 90% do? I find the 90% on the bottom and I'm going to follow my fingers up until I find where I'm looking. All right, so I'm going to do that now. So degree of freedom is 14 because n is 15. So you just pop up one number and 90 is the number on the bottom. So I scoot, scoot, scoot. I get 1.761. 1.761. There it is. When I look back at my multiple choice, There it is, 1.761. Question number 6. It states, below are dot plots from 5 different samples. Okay, this is something we've been really working on. I think it's definitely a good topic here. Which does not satisfy large sample normal conditions. Okay, so the central limit theorem, I better write that on this one. The central limit theorem states, if n is greater than or equal to 30, then the large sample normal condition is satisfied. I can move on. It doesn't mean that the population proportion, I go back to this idea. It doesn't mean that this distribution is normal. It just means that if I have more than 30 samples, then trying to find an average, and if I make a table of a bunch of these samples of 100, that is going to be normal, not this. Okay, so if I look here, it says sample A has greater than 30. So n is greater than or equal to 30 because 34 is greater than or equal to 30. So this one's good, so I'm not going to pick it. B has 32 dots, so that one's good. I'm not going to pick it. It doesn't matter that its distribution isn't normal. This is called a uniform distribution. This one is not, so we have to look into this one. This one is not, so we have to continue further in our investigation. So these all create a continued exploration. So let's go back to our paper. So creating a flow chart here. If this is a situation, then you can stop. And that's what we did on A and B. So now where do we continue? If not, we must continue. All right, so what does the continuation do? We need to look at a histogram, dot plot, or box plot. We need to look at the data itself. And what are you looking for? You're looking for strong skewness or outliers. And if you see them, you're going to stop. You're essentially going to say, no, it doesn't meet the condition. If you see no, you say nope, no strong skewness and no outliers, then you're going to say yes, large sample / normal condition is satisfied. Okay. So there's 2 ways to get to the yes, my condition is satisfied. Either I have greater than or 30 and I stop, or if I don't, then I got to look at them, look for this, and it might be a yes or a no. So let's go back to our data here. I don't see any strong skewness. I got 3 dots to the left, 3 dots to the right, and 1 little dot on the right. So there's no strong skewness and there's no outlier. So D is going to be good. Here, I don't see any strong skewness. I do see kind of data spread out. C, this is the reason why we selected it, because look, there's an outlier, people, right there. So that's why that one got selected, okay? Question number 7. 7 also talks about one of the conditions we've been talking about. So let's write this down. So what is one of the conditions? The 10% condition states my population, and I could be more than one population. My population or populations must be at least as large as 10 times my sample size. Okay, so going back to question number 1, since our sample size was 100, then the population I'm interested in making an inference about must be greater than, which is as least as large as 10 times the sample size. So the population of students I'm talking about, I want to make an inference about the population of all students in America that have a job. This population has to be as least as large as 10 times my sample size. And it really is. It's way bigger. And most of the time, it's way bigger. So this population of students that I'm interested in making an inference about must be greater than 10 times my sample size. That's all I'm saying, and that's all I've ever said. So which one says that? If we look at 7 again, it says 2 independent random samples. Okay, so it says my population or populations, all right? So if I have 2 independent samples, the first sample, so that would mean at least that population 1 must be at least 500 because that's 10 times the sample size. It can't be any smaller than that, right? And population 2 must be at least 750 because that's 10 times the sample size. So let's write that out. If N1 is 50, then POP1 has to be greater than 500. If N2 is 75, then population 2 must be greater than 750. Thanks for joining. Check out the next video for the continuing questions.